When we factor by grouping, we take what is normally a 4-term polynomial and split it into two smaller 2-term polynomials. Now, factor by grouping is a process that can work for larger polynomials. You could have 6 terms and break it into 2 groups of 3. You could have 8 terms and break it into 2 groups of 4 or 4 groups of 2. Any kind of dividing or separating that you can do that makes equally sized groups is going to work through the process of factoring by grouping. But for our purposes, we are going to focus mostly on 4-term polynomials that are split into 2 groups of 2 terms each. The splitting that we do 99% of the time does not require us to rearrange any of the terms. We should leave the terms in the order that they're in when given the factoring question. If we were to rearrange the terms, we should get an identical answer, but it's unnecessary. There's no need for us to worry about rearranging the terms. In factoring by grouping, we focus on one group at a time. So if we're looking at this first group, we identify x squared as its greatest common factor. Removing x squared from each of the terms leaves an x in the first term and a minus 7 in the second term. If the factoring by grouping is going to work, I need x minus 7 to appear in the second set of parentheses for the second set of terms. In order to get that to happen, you might notice that I need a sign change to occur. I had plus 63. It's now going to be negative 7 in the second half of the binomial. So in order to do that, I'm going to have to very carefully choose my common factor. Instead of just using 9, which is the largest number that goes into 9 and to 63, if I want to force that sign change, I'm going to have to use a negative 9. The reason that factoring by grouping works is because now we can see, if we look at this section and we look at this section, that those two sections have their own common factor. Yes, that common factor is not a common factor in the sense that you and I are used to seeing. We're not used to seeing binomial common factors, but that's what this really is. This group has a common factor, or a factor of x minus 7, and this group has a factor of x minus 7. Since they have that in common, we can imagine separating out that common factor, and then what's left over is everything that was multiplied by that factor from the two different groups. So up here, I have an x squared, and from the second group, I have a minus 9. Now, you might think that because you have successfully rewritten your 4-term polynomial as a product that you are done. Unfortunately, you are not. There has to be a step in your own mind when you get down to this bottom part where you think to yourself, is everything factored completely? This is a first-degree binomial. That factor is done. There is nothing else you can take out of there because there's no common factors. However, over here, we have one of our old factoring / multiplication friends, the difference of squares. Because x squared is a square and 9 is a square, it can be rewritten in its multiplicative form as x minus 3 and x plus 3. And this, creating those last two first-degree binomials, would be our final answer for the factoring by grouping of the polynomial with which we started.